Okay, so now we're going to talk about how to implement specifically the graph. Now that we've talked about how to implement an edge and how to implement a node, we're now interested in a graph which is created with a constructor that takes a set of nodes and a set of edges. This is going to be a little bit different than the other constructors that we did previously. And you might, if you were to take the APCS test, you might think that the thing to do is to type here this dot nodes equals nodes, and you're done. You'd think normally if this field was not a collection, if this field was not what we call mutable, that would work. But it doesn't work here because you don't want to make it possible to change this thing that was given to you from within your class. So to do that, we have to make our own copy. That means that we set our local field for nodes and edges to a new instantiation of a hash set of nodes and a hash set of edges, respectively, and then iterate through the nodes and edges that were passed to us, assigning each element of the nodes that were passed in to be added into the collection that we have, and similarly for the edges. So it's a little more complicated, but it's not that much more complicated. We just have to iterate through the collections and push them into the local fields. And then the toString method is going to say a graph with nodes as follows, and then it's going to iterate through the nodes that are represented, that are stored in our local field. And then it's going to say and edges as follows, and then iterate through each of the edges. And in each case, it's going to print out whatever the edge or node in question would want to print out from, well, not so much print out, it's going to return the toString method, the results of the toString method being called on each of those nodes and edges, respectively. And then we put in an extra carriage return at the end in order to make the formatting a little bit more readable. And guess what? That's it. In each of these cases, nodes, graphs, and edges are entirely defined by how we create them. And then whatever we do to create them causes us to then record that information in a local private field. That's true for all of them. It's a little more complicated for a graph, but it's the same basic approach. And so now here in main, having created my first graph, I can then invoke P. Now P just in turn invokes system.out.println down here, okay? So now if I run it, and hopefully I didn't introduce a typo while I was bouncing my cursor around in my code, and it is happy. And here we see it says a graph with nodes as follows, 2, 3, 4, and 1, 2, 3, and edges as follows, and it has a 1, 2, 3 pointing to a 2, 3, 4. And that's it. Now, this doesn't give us everything we need in order to analyze a graph, much less analyze the graph efficiently. But it does give us everything we need to get started. We can now represent a graph using nodes and edges.